Should probably turn my video for this too. All right, let me see. Awesome. Okay, good. All right, I'm recording. But you guys want to see the full screen? That's fine. All right. Hi guys. So if you guys don't know me, I'm Chris. I'm the president of CPU Hyperloop, and this is our workshop series. Today we're doing Arduino 2, and we're going to be learning about Arduino, and then later we're going to be soldering some boards together. It's going to be a lot of fun, and you get to program them as well. And you guys have already received your kits, so you can take a look at them, see what's up with those. But there will be a more in-depth guide later. You guys are lucky because in the soldering workshop, I didn't have enough time to make a guide, so they were all on their own. But we also have helpers from Robotics. We have Alex, who is our vice president of Hyperloop, going to be helping too, and we have all the Hyperloop members who are very friendly. They don't bite. So if you want to follow the PowerPoint, you can go ahead and copy this QR code here. Very fancy, very nice. If it doesn't work, let me know. To give you probably some time to copy that. Hey, it's 42222 today. Doesn't matter. No. Okay, so we already went ahead and signed in, so right on time, it's 5:10. Introductions were done. We're going to be talking about the types of controllers today and what you can work with in your own projects. Half of this workshop is just encouraging you to go about doing your own projects. In fact, you can actually take the code that I give you and improve on it so that you'll have more functionalities in your actual Arduino board. And then we're going to go over some lab safety because I know a lot of you haven't been to the soldering workshop, so we need to make sure you guys don't burn yourselves or anything with the soldering iron. And then we're going to be going over some of the instructions for the Arduino code. And then at 6 p.m., we're going to go build. There will be like mentors from Robotics and Hyperloop coming out to help you and make sure you don't start a fire. And then at 8 p.m., we're going to finish. Everyone okay with the schedule? Okay, so what are microcontrollers? So a lot of people say that microcontrollers are like an Arduino, which is true. But then what are you actually referring to? So the microcontroller chip is actually the little caterpillar looking thingy that's on a Arduino. Newer Arduinos have this like little square chip instead. And they're very tiny. So this is an 18 mega 32U4, which is the chip we're going to be working with today. This is like the newer version. This is like the older version. This is much bigger than this one. This is much easier to solder together than this one too. We're not going to make you solder like this one together. This one you would need like SMD soldering, which we don't teach yet. So the microcontroller is the actual chip on the Arduino board, and you can go ahead and program it. It has an EEPROM, which is an erasable memory. And the basic Arduino microcontrollers we have are the 18 mega 328P, which is used on the Arduino Uno. Yeah, it's a DIP chip, which is a dual inline package. It's pretty old, but it's good for DIY, right? Like the bigger Arduinos are usually easier to work with, and then you start scaling down to the smaller ones. The 18 mega 32U4, which is the one we're going to be using today, is newer. It's very cool because it has USB 2.0 functionality, which means if you saw the description for this workshop, we're working with a macro board, which means that the buttons you press on this board will be mapped to your computer. You actually get to control things on your computer with this board. So it's newer technology, and it comes with USB 2.0 support. There are several libraries we're going to be working with today, including the mouse library and the keyboard library. These allow for the keyboard functionalities. So the Arduino Nano, Uno, and Mega, these are the ones you hear a lot often. And I'm not going to go through like every single part of it because we don't have time for that. Last time I did this, last semester, I kind of stalled for a long time on this. But now you can click on the Wikipedia link and learn more about it. But basically, when you're doing a project, when you're deciding on doing a project using an Arduino, you have a few things to decide. A, what's my size of project, or the size of the board I'm going to use? How much processing speed do I need? How much processing power do I need? And what's my utility? For example, some Arduino boards, like this one, have more pins, more digital pins, than like an Arduino Nano. Now, obviously, if you get something like an 18 mega, those have like 30, 40 something pins. And if you need a lot of connections, you would use something like that. But if you're only using it for like very small applications, such as like reading a temperature sensor, and that's about it, that's only like one connection, you would use like a tiny Nano. So sometimes it's more efficient to get an Arduino Nano rather than like a big Arduino Uno. Although this is like most of the starting kits you have. Inside your board, you'll actually find a little silver bag with a Arduino Pro Micro. And that's what we're going to be using today. Okay, the Arduino Leo, the Arduino U, and Arduino Micro, these have all built-in USB 2.0 communication, which means that whatever you code into one of these things, you can actually control your computer with, which is really cool. It brings a lot of functionality to the table, including what you're going to be building today, and that's why we're using it, the newer versions. Fun fact, the Arduino Micro is actually cheaper than the Arduino Nano. And I'll talk about this later, but we have basically a lot of inflation happening right now, and so people are buying out all the microcontrollers in the world. If you try to find a Raspberry Pi, you basically can't, because they're all sold out everywhere. So there's this website called the RPi Locator, and it shows you all the current Raspberry Pis in the world, and there's only like 1 or 2 stores selling it left. The Arduino Nano, which is the more popular one, supply and demand lesson here, is currently about $8 to $9 per board. When I gave this lecture last semester, they were about $3 to $4, right? The Arduino Pro Micros are about $7 each, which is not bad. It's actually cheaper than the Arduino Nano. However, the Arduino Nano has more digital pins than the Arduino Pro Micro, and these boards right now use up literally all the pins on the Arduino Pro Micro. So I'm using the maximum utility to design these boards for you guys. But yeah, that's basically my spiel on this. I'm not going to go too deep into it. ESP32s, ESP8266s. If you want internet connection on your Arduino, this is how you do it. Supports MicroPython and also the Arduino IDE. MicroPython is like Python, but for GPIO pins. If you want to code using that, you can. You access it through PuTTY, through a serial communication with your computer. It's very fun. So I use this to connect to like Alexa in my home, and also to several relay boards in my walls. Like I can say, Alexa, do something. And it sends a signal to this board, which sends a signal out the digital pins, and then turns on my sync, right? So I'll read through this, I guess. Today's GPIO pins and ADCs, which is the analog digital converters. The fun part about these boards is that you can custom set SPI and IGC communication pins, because there's a multiplexer in this thing. And it also supports Bluetooth 4.2 and BLE. And actually, it's pretty low price. I mean, the comparison that people usually make with these boards is between the ESP32 and the Raspberry Pi Zero. Because they're like almost the same thing. Raspberry Pis do have a lot more processing power, but they're really rare. Like, this is not that rare. I think this price is outdated. It's probably like $15 right now. I made this last semester. But if you can't find a Raspberry Pi, you can learn how to use this, right? The downside about Raspberry Pi is that usually its GPIO functionalities are not that strong. So we'd rather go with some powerful microcontroller like this and connect to Wi-Fi. So you can send data packets to local servers and access websites and update data in external external repositories. That's the ESP32. If you want to use one of these bad boys, they're really great for connecting to like your local Wi-Fi and local devices in your home. So if you ever hear people wanting to automate homes, this is like one step to do it. Okay, Raspberry Pi. I talked about how it's pretty much impossible to get one of these things, and it pretty much still is. It's really hard to get them. I kind of want some more, but I can't. Fun fact, if you go to pishop.com, I think it's a USA-based manufacturing store. They update their Raspberry Pis once a month, so if you're on their email list, they'll send you when it's back in stock, and they don't scalp you for it too. Like if you go on Amazon, type Raspberry Pi 02W, it'll be like $69 or like $70. Guess how much it's worth? It's worth $15. And it scalps it all the way to 70. So it's expensive these days. But you go from the history of Raspberry Pi, you start from like the 0 or like the first one, second one, 0 came out next, and then 3 and then 4. Of course, like every step you go up, there's a higher quality IC chip that's in there, or the main processor, which is the BCM2711. Every like generation it updates it, and due to Moore's law, it improves over time. So you see like the memory or the RAM increases up to 8 GB, which is the one that we use in Hyperloop. We're lucky to have some of these because we got them last semester when they weren't inflated and everything. Raspberry Pi, I usually use them for Python. You can use them for like C, C++, those things too. But I usually use them to host servers, manage data. They're a lot better for servers and memory allocation than some big computers. So the Raspberry Pi Pico is also really nice. If you want something like the ESP32 but like way smaller, you can get this. And there's also the Raspberry Pi 02W, which isn't shown on here because it was like very recent, like last year. So you can see how like as it releases, I guess more and more recent. I guess that's pretty obvious. We just continue a lot of this. I don't think they're making a Raspberry Pi 5. I think a lot of us want a Raspberry Pi 5. Okay, buying knockoffs. And I'm sure you a lot of you guys have realized that a lot of this is just me ranting about Arduinos and stuff, which is like the entire point of these things. When you buy knockoffs, which is actually a really important thing, like you buy an Arduino from the official website, it's like $30-something. You buy a knockoff and it's like $9, $10, right? Used to be $2 to $3. That's like the cheap price. But you got to be careful about buying knockoffs because sometimes their drivers don't work with your Arduinos. Pros, they're inexpensive. They're relatively easy to acquire because they're all over Amazon and all over like Alibaba and whatever. And they're a simple replacement because it's really easy to burn out one of these things. Like one wrong connection and you start to smell burning smoke from the Arduino. Believe me, it's a very recognizable smell. And then you have to replace the whole thing. Do like one of the chips burn, or the voltage regulator burn, or something like that. So buying knockoffs is good because you have easy replacements and they're pretty inexpensive, but they may not always have the right bootloader. They can be soldered badly, and the USB ports are flimsy. So one story about this is that when I designed the macro boards, initially I used the Key Studio, the black PCBs, but I switched away from them because they were really flimsy. They had like really flimsy connections because their USB ports were SMD connections and not through-hole. The SMD connections will break up easily because the USB ports get used a lot. So what the ones you have right now, the Kukai ones, they have their USB ports soldered into it like a through-hole. And that gives it a lot more stability than otherwise. So here's a knockoff board that worked. This is really outdated because this is like really expensive now, like $27.99 for 3. I used to buy it for like $13 for 3, but I guess inflation. So yeah, things are getting more expensive, especially these boards. Something to invest in, I guess. Okay, before we get into this, any questions about Arduinos that you want to answer? I'm going to toss some questions from memory based on what I saw on the questionnaire that you guys signed up for. There was one about Python and Arduino, which is really interesting because that's the technology we used in Hyperloop. To connect Python script to an Arduino script, you would have to connect your Arduino to a computer through a serial port. So you literally just take your Arduino, plug it into your computer, and then you use some software like PuTTY, so P-U-T-T-Y, to access the serial ports, so like a specific COM port that your Arduino is on. They call it COM ports. Like you can access your Arduino's data. And if your Arduino sends some data to your computer, then you can use the Python serial library, so a PySerial, in order to grab that data from it. You can build like some kind of sweeper system, so to sweep past through the COM ports on your computer to find the correct device, and then start reading data and writing data. Now this is useful because your computer has a lot more RAM than your Arduino. Arduinos have like 32 kilobytes of RAM, so very small amount, not much memory. Arduinos can't even multi-thread, which means like you're running 2 functions at the same time. Usually Arduinos only read from like top to bottom. So you would pass data into like a computer or a Raspberry Pi, and the Raspberry Pi would do more complex tasks like data management and connecting to a local server and sending data off to that server. So like for example, for Hyperloop, our pod uses a Raspberry Pi Arduino system in which we send the data from the Arduino to a Python script. And in that, we have the Raspberry Pi send that data from the Arduino to a server that we can parse the data on. And so that's just one example. Of course, there's a lot more examples you can do with Python on Arduino, but it's very flexible. So there is a way to get data from Arduino to computer. That's my conclusion statement. I don't remember anyone else's though, so let me know if you need anything. Okay, so you guys are going to be soldering today. We have solder from the soldering equipment from IEEE. So a little bit about safety, so you don't burn yourself. I burn myself a lot, so probably should listen to this. So part A, wear appropriate attire. Tie your hair back if your hair is long, and no open-toed shoes, because you might drop solder onto your feet, and that's ouchy. Watch out for solder splash. Sometimes when your solder gets too hot, it likes to explode and jump back at you, and that's painful. There's not much of a way to watch out for this. It's more or less gotta just And make sure you be careful not like jam a huge piece of solder into the soldering iron and melt onto the pin. Always assume the soldering iron is hot, even when it's unplugged. When you solder, it's kind of like you're holding a very hot, you are holding a very hot iron at all times. But even when you turn it off, it's still going to be hot, right? You kind of want to avoid touching that for like a solid 20 minutes after that. And after 20 minutes, you don't touch it at all because you always assume the soldering iron is hot. Okay, so like even with the solder, when you put the soldering iron on the stand is metal, so don't touch the stand either. Things are hot here. Like this thing gets up to 480 degrees Celsius, which is 895 degrees Fahrenheit. That's like hotter than when you usually cook. So things are hot here. Anyone want to tell me what's wrong with this picture? Yeah, stock image. Favorite stock image all time. Next point, always tin your iron before using it. So I got you guys some very nice tip tinner. They're like these small metallic tin thingies that you dip your soldering iron in and make the tip very conductive. It makes your soldering experience much easier. Now, whenever you see your solder tip be like not conductive, just go ahead and dip it into this little tin thing, and it'll coat it in like a layer of solder, which makes it really nice to apply to a board. Secondly, you can also use a metal sponge. A metal sponge is made of metal, obviously. But if you stick it in the metal sponge and twist it around, it'll also coat the tip of the soldering iron very well. So we provide you with metal sponges and tip tinner and soldering iron and pretty much everything you need. Okay. Oh, and I said again, always assume your iron is hot at all times. All right. Last time during the soldering workshop, I don't think I had any burn complaints, which is impressive. But if it's your first time soldering, just be careful. Next page is solder safety. Always place the iron back in its holder before doing anything else. Allow for some slack in the power cord. This is important. I mean, not as important as the lab because when you're doing the lab, the power plug is like right next to you, right? And at my home, it's like not right next to me. It's like I'm sitting here soldering, and it's like this far away. So when you're soldering like that, you want to make sure you have some like leeway or giveaway for the soldering wire, so that if someone walks by, they don't trip on the soldering wire and have the soldering iron go flying across the room. Have you guys ever seen like something that's 480 degrees Celsius fly across the room? Yeah. What's that? It's pretty dangerous. I have never seen it. I don't want to see it. So, turn devices off when not using them for a long time. Not only is this safe for yourself, but also safe for the soldering iron, because the longer it is turned on, the more it'll destroy itself. You gotta be careful about that. Like the tip of the iron will rust, and actually a lot of the soldering irons I've seen in IEEE are actually like this, of like this quality. So you gotta watch out for that. Also, ventilate the area. If you're home soldering, make sure you buy like an exhaust fan. If you don't want to buy an exhaust fan, just open the window or open the door. But solder fumes are dangerous. If you buy lead-free solder, they're not as dangerous. I have lead solder in the room, which is flux core solder, which is dangerous if it's lead. But as long as you don't like breathe it in, like a lot, it's really fine. Flux core solder, I like to advocate for it, even though it has lead in it, because the flux inside actually makes your connections very nice. It oxidizes your connections. That's pretty good. And the last thing is blinky learner special. Do not stare into LEDs for a long period of time. This doesn't apply here. There's no LEDs in your boxes. But back when we did the soldering workshop with blinky learner, we had LEDs, and if you stare into them too long, you'll go blind. So, fair warning. Oh, yay. Now's my favorite part. Okay, so we're going to be building programmable macro boards today. There's a huge QR code on here, which has the instructions. So if you guys want to scan that and get them to your computer, we're going to be going over the instructions a bit. Now, I'm gonna go ahead and say that didn't have much sleep when writing these instructions, so please feel free to call me out in any errors. Let me just give you guys more time to copy that. What? What last time? Yeah. Yeah, Yash will see. I sent Yash a note. When I gave Yash the board for the first time to like try it out, I gave him note, like a full 8 by 11.5 inch of paper with like scribbled notes on how to build it. It's a little better now. Yeah. So this is my website. I finished it 3 hours before this workshop started. And you can go ahead and follow this, but I'll just go over it real quick. So what we're building today is a programmable macro board. I spent the entire week putting 60 kits together for this. But you press the buttons, stuff happens on your computer. That's about it. You can read through this. It's pretty cool. There's a table of contents. There's basically 10 steps to this. Some of them are really easy. Some of them are a little bit harder. But you'll basically be soldering stuff, putting jumper cables on, and screwing things together, and playing with Arduinos. And this is a big excuse because I know my design could be better on this. I developed this in about 3 months and didn't give it another thought. But the keys are cool. The rotary encoders are cool. When you put this box together and hide all the electronics inside the black box, it's cool. So you should have seen the breadboard one. I had like one where it's all wired up. You hot glued that one, right? I hot glued that one. Okay, so let me zoom in on this. The construction guide. The materials you'll need. In each of your boxes, you'll have these components. Now I've labeled them so we can all communicate using the same wavelength. There's part A through F and then bag 1 through 5 because there are loose pieces and then bag pieces. Part A is the 3D printed case, which is the bottom piece. Part B is the 3D printed case, which is the top piece. So there's a bottom and top piece. Part C is the custom PCB I designed for this, which routes all the mechanical keys together and the rotary encoders and all that fun stuff. Part D is the Arduino Pro Micro itself. Comes with this little silver bag, and it has header pins, so you can solder them on. Part E is male to female jumper wires. You have 2 sets of 5, and these are fun, and also a little flimsy, so try not to break them. And then part F is USB 2.0 A male to micro USB female cables. And depending on what you put on your form, this may vary in length. If you got a 10-foot one, you won't be able to stuff it inside the box, unfortunately. Otherwise, you guys can, like, when you guys screw it together, you can actually stuff the entire cable inside the box. I didn't know you could do that until, like, I tried it. But you can, and it's kind of convenient. Okay, so those are the individual parts. Now for the bag. So bag 1 has 3D printed keycaps. So you want to use your own keycaps later, that's completely fine. So these are just for your satisfaction. Bag 2 contains Acro CS switches. These are pretty good quality switches. I use them on my keyboard. I'm not a keyboard fanatic. My friend just told me these are good. They're pretty good. Bag 3 contains Siloid KY040 rotary encoders. Now these have detents, which means that when you turn them, you'll feel bumps. I'm looking to get some like without bumps for like the next version of this. But for now, these will come in like these little modules that you'll screw into the boards, and they work. Do they work well? I think so. Bag 4 contains screws. You should have 4 black oxide screws, which are the black ones, and the 4 silver screws, which are the silver ones. The black oxide screws are M2.5 by 6 millimeters, and the silver screws are number 6 by 32 ones. So we talked about screws in like the previous workshops, but these are my favorite screws. These ones, M2.5 by 6s. I have like 1,200 of these. I specifically bought like 12 bags of 100s from the car the other day, because like I just wanted like a huge thing of them. Bag 5 contains female pin headers. There are 2 12 pins and 2 5 pins, and these are individually cut, all like 60 of them. So pretty fun. These will be soldered onto the board. We'll go over that in a little bit. And the required tools: you need soldering equipment, ventilation materials, pliers, side cutters, screwdrivers, masking tape, and a computer with Arduino IDE. If you didn't bring your computer today, that's completely fine. We'll go ahead and help you program the board using my computer with all the code and everything running. So it's okay if you don't have a computer with Arduino IDE. Some computers also don't like the fact that it's a cheap Chinese knockoff again, so you may need a custom driver for this. Just a fair warning. Okay, now I'm not going to go through all the steps, but I'm going to point out a few important things. So when you're soldering this together, you'll go ahead and make sure you don't do these steps, right? First thing first is when you're soldering in header pins, do not solder all of them in at once. because that's dangerous. When you solder in like a row of header pins, if you solder all of them, you're never getting that thing back out. It's gonna be really hard to. Like even if you use a wick and try to suck all the solder out, some like little itty bit of solder might still remain and weld itself to the pin. So do not solder all the header pins in at once. So you may be asking, well, how do I solder this in? So I'm gonna go ahead and play this video. There's 10 different videos for putting this thing together. I'm not gonna show them all to you. I am gonna show you the technique. So what you wanna do, is you wanna go ahead and solder the leftmost pin and the rightmost pin of the header pin together. And then after that, if you see that you have stuff you need to adjust, you're gonna hold the board in your hand, heat up the pin, and then like slowly tilt the header pin in the right direction. And I think I'm gonna go ahead and play this. Prepare a metal on the surface. It makes it a little shiny, just so that easier to kind of see. So like I said before, we're gonna go ahead and solder the pin to the leftmost corner. Just a little left solder. Shouldn't take too long, only 3 to 5 seconds at this point. And then pin to the rightmost side, 3 to 5 seconds. And I'm also going to solder the bottom area. And the right. So note how I have not soldered the middle pins yet, because I may or may not want to change some of the orientations. Okay, a couple of things to note there. I have masking tape. You guys will have masking tape this time. Make sure you guys use the masking tape to just hold your connections down before you solder it. And again, only solder the pins here, so that in case you want to adjust your header pins on the back, you can. Because once you solder all of these in, there's no going back, right? I'm not gonna have you guys spend 2 hours trying to do this. I did this once. It was horrible. So don't waste your time. Make sure you solder the ends first, and then everything else with it. And use masking tape to hold it down. So I think further on the video. So this is a good angle. This set of pins is a little bit too far to the right, so I'm going to go ahead and press this inwards while heating this pin up. Now this is a very fancy technique. But you gotta be careful because like these pins will get hot because they're metal, so it's conductive. So if you go ahead and touch this while heating this pin up, you're gonna burn yourself. Ask me how I know. Okay, so let's take a look at how I fix this first. So you're gonna push it inwards. So I'm going to apply some force, to these wires, and then heat the solder at the same time. I'm not going to touch this pin because it gets really hot. I'm going to heat the solder. Oh, it's lagging. All right, it's okay. You guys can watch it on your own. So I'm going to heat the solder, and then I'm going to bend it. I'm going to push at the same time it heats up, so that I get adjust it over. So after I push it a little bit, you can see that it's nice and straight. And I can go ahead and solder in the rest of the connections. This not only goes for Arduino, but also for your header pins, and also for anything else you might solder in the future. If you solder in header pins or DuPont connectors or any of that sort, make sure you do it correctly. Let me see. You can also read this stuff. The second case is sometimes when you solder in, let's say this is your board and this is your header pins, it's sometimes not flush, right? It's sometimes like a little bit above where you want it to be. And like actually these are like fun because if you heat it up and you press down at the same time, you'll hear like a satisfying snap because the header pin will snap flush with the board and then it'll be shut. But again, you can only do these things if you solder the first one and the last one. Anything else in between, if you solder it, you're not going to get that out, unfortunately. Solder, like, it's really hard to get loose. So just keep that in mind. Soldering the female heads to the PCB, same deal. make sure you go ahead and solder the first pin and the last pin, adjust it, and then solder everything in between. So if I play this, also, temporary, same as before. So you can see here how I went ahead and taped this, the PCB. Come on, it doesn't want to work. So I taped the header pins to the PCB in order to get it to be straight and for it not to fall out when I solder it together. But this doesn't guarantee it that the header pin will be straight. So just make sure you do the same technique as before. In this design, you have to be very careful and check each step along the way. Because as you get more and more into the building process, it's going to become harder and harder to fix your work as you go along. So just make sure you check your work as you go along. And it's not as dangerous here yet, but when we go further along in the building, you'll see why. Third step is you want to insert the PCB into the 3D printed case, and in the back of the 3D printed case there are 4 mounting holes, 1, 2, 3, 4, and you just go ahead and screw this in. So once you screw it in, you're not going to be able to change your soldering connections. At this point, make sure you double check your work, make sure everything is soldered together. Make sure all PCB connections are correct. There's no going back and fixing your previous work after this point. Okay? And I'm saying this because I don't want you guys to waste a lot of time unsoldering, desoldering. So that's why I got a lot of people to help me today. Because during the soldering workshop, we only had me and Sophia, but this time we have more. Just to make sure you guys don't mess up on this, because it's really easy to mess up. I've done it a lot of times before. Sometimes I just completely forget to solder each connection together after I check it, and that doesn't work. So when you're building this thing, make sure you double check all your steps. But this is just fitting the PCB into the cover. When you do that, it actually snaps together really satisfyingly. A lot of the tolerances here are very close to exact. So just make sure you give it a lot of force, push it all the way in, and it should be flush with the bottom. Next is you're going to solder the mechanical keys. So on the front, after you go ahead and push the PCB in, you're going to see that the front of the PCB is going to have these holes. And these holes are for the keycaps themselves. So when I was designing this PCB, you have these footprints that you can use. You tell the manufacturer, hey, I want a mechanical keycap right here. And the manufacturer will do that for you. The keycap will slide into this 3D printed part and into the PCB. So you can see how tolerances play a really important part in this. They go in with a satisfying snap too. So, and also when you're doing this, make sure it's all the way flush with the keyboard. You can press really hard if you have to. But again, once you solder these in, there's no going back. So they're going to snap in, and then at the back you can see that there's 2 pins we sticking out of the PCB. So you're going to repeat the step for all of the 7 holes. So you can do that by snap. Once you snap all of them in, go ahead and do a visual check in the back to make sure all the pins have gone through. They should be sticking out 3 millimeters for each pin. If something looks off, if one of the pins is not sticking out as much as the others, go ahead and flip it around and check again. Make sure that all of the keys are flush with the board. When we are all on visual inspection. Make sure you go ahead and check this now, because if you don't, it's going to be really hard to change this. So, once that's done, we'll move on to step 5, which is we're going to solder the keys together. Now, this is the most important step, because there's kind of no going back after this. You want to make sure all your keys are nice and flush and ready, and double check everything, visually check everything to make sure everything is in, because it's going to be really hard to unsolder this.
Maybe I should have more.
When you solder the keys together, you're going to have to apply a little more solder than usual. These holes are a little larger. You go ahead and Get our soldering iron out. And I'm going to go ahead and apply a lot more solder than usual to the key. So you can see how I have a very nice connection here. And then I'm just going to repeat with the rest of the connections. So I go ahead and push some soldering, and lift. And if I check to the side, you can see that there's a little nice Hershey's Kiss shape on the key. And the key is basically fused with the board. There's no going back after this. I'm going to repeat with the rest of the keys. So because of time, I'm not going to show all of it, but you guys get the point, right? Now, I talk about this doomsday stuff, like there's no going back, whoa. But there actually is. We have solder vacuums for you guys. So if you guys do mess up, the way you use the solder vacuum is you just heat the connection up and you press the button and it sucks everything out. So it's very cool. I want to get to the Arduino part because that's this workshop. So let me just scroll down. Step 5 is apply keycaps. That's pretty easy. Just get the keycap, snap it on. Step 6 is screwing in the rotary encoder. So you do this through the bottom, and these are like little breakout boards. So you connect them with jumper cables and can connect them to the PCB. 7 is you attach jumper wires. Oh, this is important. So you got to make sure you connect this right the first time. Let me just play this video. It's 2 minutes. It doesn't matter which side you have this on, but it's very important to maintain the order in which you use the. So I find the easiest way to do this is to rotate the rotary encoders to the side 90 degrees, and the female side will go into the pins. And I like to make sure that the jumper wire is straight before applying the pins in this orientation. Just jam it in like that, and note that. So right here, I'm going to stress this a little bit. You want to make sure that when you plug your jumper cable in, it's not like twisted or anything. If you see like green, yellow, orange, red, brown, you want to make sure it's green, yellow, orange, red, brown the whole way through, and not just like part of it. So it's the same thing with the other pins. They're like a one-to-one connection. So green goes in green, yellow goes in yellow, orange goes in orange, red goes in red, and brown goes in brown. In order. And then you just turn the rotary encoder 90 degrees, face it back, flush with the board. You're going to plug this into the 5-volt connector here, but make sure it is still straight and there's no twists. So it's going to go directly in the same order into the 5-volt. You see the blue is on the right. Not blue, it's brown. And that is red, orange. I'm not colorblind, I'm just tired. The colors might be different, but it should match the orientation that's going on. Just going to repeat the other side. So you repeat the. Yeah? Oh. Someone called me? Okay. So yeah, you just repeat it with the other side. But there's written instructions here too, so you can go ahead and follow that. Look at all those warnings. Okay, and then you insert the USB into the box, attach it to the Arduino. You close it and screw it shut using the outer screws. If you have a 1 foot, 3 foot, and 6 foot cable, you can stuff the entire USB cable inside the box, which I think is good for transportation. And then here is the fun part: programming the Arduino Pro Micro. This is what you're here for, right? Programming the Arduino. So if you don't have the Arduino IDE and you want it on your computer, go ahead and just type in Arduino IDE download. And just get it from the website. It'd be cool to have your own IDE. I would suggest you get the Mac OS X or the Windows one. If you want to get Windows, get the zip file. This is the real Arduino. Don't get the don't get the Microsoft one. Get the zip file. All right. But this is how you're going to program your Arduino board. You can also download the code for it in the GitHub repository, and we're actually going to talk about this a little bit. So this is my repository for all the code that goes into the P macro boards, which is short for Programmable macro boards. And the INO files are what what's going to go. That's the main file or the top file in your code. Now, if you want just the easy way out, which I actually made this for you all, if you just go ahead and change these values to like whatever keys you want or whatever hotkeys you want, then they'll automatically map themselves to the rest of the code. Same with the left button, same with the right button. If you want multiple keys or like volume control or anything of that sort, the base code is here for you, and I would like to encourage you to figure that feature out and expand on this code and improve on it. Now, GitHub has a feature in which you can fork this repository, or you can just copy it straight from here if you want to improve on the code base. But just as a simple way, button A, button B, button C, button D, these are the 1 unit keys. These are the middle row. The left and right bottom buttons, the start button, then the encoders. So if you turn the left encoder left, LL, you'll get W. LR, you get E. If you turn the right encoder left, you get O. And if you turn the right encoder right, you get P. And the encoders themselves come with buttons as well. So I mapped it so that the button on the left will press the left arrow, and the button on the right will press the right arrow. Now these are characters because these are ASCII characters. But just to be simple, this is how it's done. When you're recoding this, by the way, make sure you put quotation marks, like single quotation marks, instead of double quotation marks. Single quotation marks represent characters, double quotation marks represent strings. Strings are a lot larger than characters, so it breaks it. It doesn't like that. But let me go ahead and go over some of the code first, just so you guys get an introduction to Arduino. So in every Arduino code, you have like basically 3 parts, right? The first part is where you declare all your global variables and your dependencies, and you set up all your classes. So I have here my include mouse and include keyboard, which is my importing the dependencies. And then I have here, I instantiate all my variables. That's the first part. The second part is the setup function. So the setup function is a function that runs once. So if you want to set any pin modes, which you want to say the input pin is like, or sorry, if I go down, you can see that I'm setting the pin to an input pin, or a pin to an output pin, or a pin to both input and output. If you ever taken Verilog, it's kind of like that. It's really important, though, I set it as input, because the way it's wired electronically in the PCB is that the mechanical keys are connected directly to the pin and then directly to ground. So it basically sorting itself into the rails. Now, normally this would be very dangerous, right? If you're just connecting a connection, because the mechanical key is kind of like a lever, right? You have 5 volts here, you have ground here, and you have like a thing going into the pin. If you short the 5 volt and ground, then the Arduino will realize that and say, hey, the key has been pressed, right? That's how keyboards work. However, if you do that, then you're like, wait, am I creating a short between 5 volt and ground? That's kind of dangerous, right? The Arduino has an internal resistance. I think it's a pull-down resistor that prevents that from happening. But it only activates when you set the pin mode to an input pin. So it's really important that you get that right, because an output pin would be if the Arduino is sending a signal outwards, and that's a different story. So all the buttons, all the encoders, all the everything, they are inputs. So when you're working with Arduino, you want to define your inputs and outputs using the function pin mode. Okay. Now the next thing is digital write. In Arduino, we use digital write to write out something to a pin, or digital read to read in some input from pin. Here we set our buttons and all the buttons to a digital write of high, because that's its default value. We want to prime it with that default value, because when we press it, it'll actually turn to low. And the circuitry behind that is pretty interesting. You can Google mechanical key circuitry to see more about that. But it's an inverse logic. So just remember that when you don't press a key, it's on high logic, and if you press a key, it's on low logic. Okay, inside the setup function, you can also declare your serial output. So if you want to see something in your serial monitor, like a print statement in Python, you go ahead and set the baud rate to whatever you want. Like I think it's usually 9600. But here I also begin my classes and dependencies. So mouse.begin, keyboard.begin, and keyboard.release all. So again, that is the setup function where everything happens once. So it runs through the setup, right? It's really adequately named. It's called setup. You run it once through the setup, and it's done forever. It's not going to come back to this. So next is the loop. As I told you, Arduino has 3 parts: the variables, the setup, and the loop. So the loop runs forever, basically. It runs forever. You can trap it. It's basically an infinite loop, kind of. but it's a really useful infinite loop because in Arduino you can do a lot of stuff with it. Just remember the timing is a little different than regular code. It runs over and over and over again. So if you want to change a variable, make sure you do it globally. So in this case, what we want to do is we want to detect what changes every time it loops. So if we press a key on the macro board, we want the Arduino to say, hey, something changed, right? So if we pressed button A, we want to go ahead and activate a keyboard press of button A, right? This keyboard.press can only happen if you have a microcontroller with an 18 mega 32U4 chip, right? Because this has the USB 2.0 connection. So if you do keyboard.press button A command, this will give you the whatever the button A command was. I think it was D, right? And then if you don't read this, then you're going to release it. So press, release, press, release. Same for the other. So it's same for B, same for C, same for D, and all of this logic is pretty much the same. This little function right here, digital read, is really important because it reads whatever comes from the digital pin. This thing has a delay of about 5 nanoseconds. Don't ask me how I know that. But it's a very small delay. So if you're dealing with timing in your code, that's probably something to watch out for. So if digital read is low, then you're going to press it. This keyboard.press just like presses it in the Arduino, which sends that signal out to the computer through your USB cable saying, hey, simulate a press on that key. All right, same for C, same for D. And nothing else interesting happens until we get to the encoders. Because all of this is just button logic, right? Buttons, when you press it, it turns on. When you let go, it turns off, right? In this case, if you press it, it goes low. If you release it, it goes high. Low in this case means like 0, and high means 1. It's just a different way of representing it. So those are fun. And now we have the other fun functions. So these are rotary encoders. Rotary encoders come with like 2 little metallic wheels inside of them. And when they turn, the voltage changes in one direction. And an Arduino can actually detect this. So we actually use a library called the encoder, so we don't have to do any of this work. It just does it for us, right? And basically, it has 2 values, the current value and the old value. Now, if the old value is less than, or if the new value is less than the old value, then it'll press the right turn, because it's turning this way, right? The top one's turning, one of them staying still, but this one's turning, because you're turning the knob. The vice versa for the other one. If you want to look further into the encoder one, I haven't read the entire library, but it's a lot of hard code, a lot of low-level language that makes rotary encoder work. All you need to know right now is that if the current value is less than the older value, then it's going to turn right. Otherwise, it's going to turn left. Save for this, update nonce 2. So for each update nonce function you have, that maps it to a specific rotary encoder on your board. And since you have 2, you need 2 separate functions. These are functions, by the way, in Arduino. Don't know if I described that yet. But that's how the rotary encoder works. I'm sorry I don't have like a huge slide for rotary encoders, but like they're pretty cool. They're like potentiometers, but infinite. And they don't measure resistance. Okay. Are there any questions as of right now? I know you can just upload this code.
You know how we can change like the top values to be like what we want it to be?
Yes.
So if I want to do like shift or like control something, like how do you combine?
Good question. This does not have the functionality for that yet. So again, as I said, it'll be up to you to figure that out, or if you want to wait a week for me to put that in, you can. But dual keys require a bit more logic. So when you press it, and you want to press control and something else, you're going to have to put that somewhere inside one of the button commands. So here, if you want to do 2 keys instead of 1 key, let's say control and R, you can do keyboard.press control and keyboard.press R in the same block. Maybe you can separate that with like a delay of like 5 milliseconds or something, so the computer doesn't recognize it immediately. But as long as you have this pressed and then like another key pressed, it'll press both of them on the computer. So it's not exactly user-friendly, as I mentioned it, but you can modify the hard code yourself to make that happen. Same for volume. I know volume is a specific key on a keyboard, maybe like F4, F5. Those do exist as part of the mouse and keyboard library. So you want to know how to do that, you read the dependency or the documentation of mouse and keyboard. Mouse also allows you to move your mouse left or right. So if you can map that to a rotary encoder, you can like move the mouse around the screen too. So that's the usage of the Arduino Pro Micro, which has the 18 mega 32U4 chip. Simplest way to use this code right now, though, is just to change these letters. You get the more complex stuff later. Yeah.
That's a question. So like that's when you're trying to click 2 keys, right?
Yeah.
What if I wanted just 1 key that equals just control copy, like control C? Is that possible?
No. Yeah. Maybe there's something in keyboard that has it, but not to my knowledge.
Like 2 values up there.
Yeah, you can do that. You can do that. Maybe. You can put it as a function. Yeah.
Is this C or Python?
So Arduino is a mixture of C++ and C. So you're coding using pretty low level language. And I can actually show you this. So if you scroll down to the languages, GitHub detects it as 80% C++ and 18% C. Any more questions? Yeah.
Could you post the instructions to Discord? It wouldn't work now.
Okay, let me go ahead and put it in the Discord channel. I know it's a Google site. My .tech domain is still loading. I'll put it in the announcements, or I'll put it in general. No one ever uses general. All right, there you go. Okay, and so before we go ahead and actually, you guys can watch this video yourself, right? Or read this. This is just teaching you how to upload the code to the board, but I'm sure you guys are all antsy to go ahead and build this thing, so let's go. So it's 6 p.m. We'll leave this up here if you want the instructions. Yeah.
So every time we upload it, like every time we turn off the board, you have to re-upload it?
No, it's not FPGA. It saves it.
Oh, it saves it? Okay.
Yeah.
Okay.
Yeah, that's useful, huh?
No, it's volatile memory.
Oh God, no.
Oh yes.
All right.